Assalamualaikum and have a good day. So let's continue on the next topic, frequency response design via LED compensator. So the design objective for LED compensator is first to improve the steady state error by improving the static error constant, either KP position, KV velocity or KA acceleration static error constant based on type 0, type 1 and type 2 by increasing only the low frequency gain without any resulting instability. And second objective is to increase the phase margin of the system to yield the desired transient response, either TP, peak time, or TS, settling time. So using the lag compensation, we compared the dot plot of both uncompensated system and compensated system. The light green is for uncompensated plot. This is magnitude and this is phase. And the dark one is the compensated system plot. This is magnitude and this is phase. So based on lag compensator, it doesn't change low frequency gain. So at this low frequency, the magnitude is almost equal at the low frequency, but for higher frequency, the shape is different between two types of system. The uncompensated system finish at higher frequency, while the compensated system settle down at lower frequency compared to uncompensated system at this high frequency area. Okay, the uncompensated system is unstable. Okay, cause gain at 180 is greater than 0 dB. So this is negative 180 degree. So for uncompensated system, you go to magnitude plot. The LM is negative. When we determine the gain margin, it will become negative. This LM is positive. When you determine the gain margin, it will become positive. While for compensated system at negative 180 degree, okay, so this is the compensated phase plot. When you go to magnitude plot of the compensated system, this is negative LM. So when we calculate the gain margin, it will become positive gain margin. So compensated system is stable compared to uncompensated system, which is unstable. The magnitude curve of this dot plot, okay, this is magnitude and this is phase. The magnitude plot, the magnitude curve can be reshaped from this position at 0 dB to this position at 0 dB for compensated system, where we reduce the higher gain frequency. This is higher frequency, this is lower frequency. We reduce the higher frequency from this point to this point to get the stable system compared with unstable system for uncompensated. So there are 8 steps in designing the frequency response via lag compensator. So we go one by one. The first one is to determine the system gain K to satisfy steady state error and plot the plot diagram for this value of gain. Okay. Second, determine the new gain crossover frequency we label as omega PM prime. With the consideration of correction factor CF that will be given in the question. Usually the correction factor is between 5 to 12 degree greater than the desired phase margin. Next step is to determine the magnitude of the frequency response. At the frequency response, find in this one. So at this frequency, we go to magnitude plot and we determine this value of magnitude from the magnitude plot. And then based on this one, we select high cutoff frequency, which this high cutoff frequency is actually the compensator 0 of lag compensator. And then we determine by select one decade below this value. Okay, 0.1 multiplied with omega PM prime. That is the ZC or high cutoff frequency. And then based on this one, based on step 3, we invert the value of this one by make it negative, and then we draw the asymptote, which is the straight line along this value. And then based on this one, we select the low cutoff frequency at 0 dB by connecting this high cutoff frequency and low cutoff frequency with negative 0 dB slope. And then that low cutoff frequency is actually the pole compensator of the lag compensator. And then in step 8, we determine the K lag, the unknown gain for lag compensator. And then we determine the compensated transfer function by multiplying the lag transfer function with the original open loop transfer function to determine the compensated system. Okay, we continue on the next video by doing step by step from step number 1 until step number 8. Till then, thank you.